All right. Hi, guys. How's it going? I hope you're all doing well. Welcome to Chemistry 3003 Orgo Lab with me, yours truly, Michael. So obviously everything is going to be a little bit different now that lab is going to be fully online. As such, we're going to be doing things asynchronously, meaning that we won't actually be meeting at the predetermined lecture times, but I will be posting videos like these on the day of, describing any relevant chemistry or any relevant materials needed to understand how to do the lab and how to write the lab, what's necessary for the lab, et cetera, et cetera, et cetera. Or alternatively, for some labs, I will be posting YouTube videos that describe it just as succinctly as I could have, and you will be using those as your knowledge for writing the lab report itself. All right, so I'm just going to skip right into the syllabus. So the syllabus, obviously, for Orgo, lab, and lecture are the exact same thing, but I'm just here. Oh, this is the wrong. This is it. Right. So basically, the summary is that if you skip down, the laboratory grade is going to be 22% of your Orgo grade. So as such, these labs that you're going to be handing in will be graded and will be counted for your grade. All right, we are the JMWA section, meeting on Mondays from 9:05 to 11:35. Okay. So everything that I post will be on Blackboard, meaning course documents, syllabus, all that stuff you're going to find on Blackboard. Uploading assignments also you're going to be finding on Blackboard. All right. I'm going to upload lectures covering the assigned chapters, and we'll upload them to YouTube just as Dr. Wap is going to. Typically, they're going to be at the scheduled times, but due to the whole posting stuff in the wrong Blackboard link, this one's a little bit delayed. But in the future, they're all going to be exactly at the same time. All right. So demonstration videos will be assigned for each lab. Sometimes it'll be literally me doing my own Zoom lecture, giving you the relevant chemistry. Other times it'll just be YouTube videos. And from there, if you guys do want to follow up with questions, I will have a different meeting time that is not the active meeting time on the schedule. So my office hours will be Thursdays from 8 to 9, specifically just for asking questions, or 12 to 1 if you guys want to do by appointments for privates. So if you have any specific questions, you can reach out an email and we can schedule something from 12 to 1, something along those lines. All right. So you get a 10% penalty each time the lab report is late. All right. And each student is going to be required to turn in an original lab report. We have specific algorithms that check lab reports to see if they're similar to each other, and if two lab reports are similar enough to each other that it flags them, the people that wrote them will receive zeros. Your lowest lab report is going to be dropped. All right, so that means if we write 10 lab reports throughout the semester, one of those lab reports will be dropped. Okay. here you can see all the different lab assignments that we're going to be doing. So next week, we're going to be starting with melting points, and from there, crystallization, fermentation, et cetera, et cetera, et cetera, et cetera. All right. Please feel free to email me with any questions that you have. I'm always responsive within 2-ish days at my emails. So you guys have any questions, feel free to reach out. All right. So now we're going to go into the general lab format, and then I wrote my own article on how to write lab reports that we can look at afterwards. All right. So this is the general idea. You're going to top it off with your name, Chem 3003, and the date. And of course, you're going to put the title of the lab. All right. Then you're going to have an abstract, which is about 120 or less words, summarizing the entire lab with your final numerical results. So it should have like 1 or 2 sentences from the intro, 1 or 2 sentences from the results, 1 or 2 sentences of discussion, and then 1 or 2 sentences of conclusion, all including the final numbers and results. All right. In the introduction, you're going to introduce the purpose for the lab, which is the problem that you're facing and why that needs to be addressed. Then you're going to put the theory behind your experiment, which, if you're doing this right, should probably be multiple paragraphs, if not a page or more in length. So, for example, if you're going to talk about the purpose of the melting point lab, the purpose of the melting point lab is that you're going to be using melting points as a way to determine the identity of unknown substances that you're synthesizing in the lab. All right. And the theory behind the experiment is going into why objects have melting points, why the melting points are different from others, hint intermolecular forces, and how melting points can be used to identify different compounds between each other. All right. Then you go into a general theoretical treatment, which is, of course, what you're going to be doing in theory. So write it as if you're going to be writing about something you're going to be doing in the future, so you haven't done it yet. All right. I know that you guys have already done it by the time you're writing this lab report, but imagine that you're writing it for the first time. In fact, even if you want, write the intro beforehand, before you do the lab, so that it's a little bit easier to do this or get into that habit. All right. You don't use past tense in the introduction because, once again, we're assuming that the introduction is written kind of like before you did the lab report. And of course, as scientists, we do not use first person. No I, me, we, or our. All right. Then after the introduction, you're going to have the next section, which is your reaction scheme or the compound studied, which you're going to put down the compounds, their relevant properties like their melting points, densities, boiling points, color, luster, et cetera, et cetera, et cetera. All right. And reaction schemes. You're going to show the reactions that you're doing as well as their relevant mechanisms. Okay. You can see the general format over here. All right. This is the only part of the lab that is to be hand-drawn, handwritten. With the whole online submission situation, it might be a little bit different. But generally, you can just scan it and upload it as a PDF. Okay. So, and then you give the mechanism. So you have a reaction scheme, which is the general reaction and final product. Here are your, things that you're using. Here's the final products that you're making. And then, of course, you're going to have the mechanism, which is the exact flow of electrons, the exact changing of the bonds step by step. So in full detail. All right. Then you have your results and discussion section, which is a brief outline of your procedure. Okay. No need to put in things like a change color or anything like that. Just be like, here's what was done in past tense this time because it was done, without putting any opinions, okay? So the most important thing with the results section is you don't want to put your opinions. That's for the conclusion section, okay? The discussion section is where you discuss the actual it's like in the results section, you give the results as the unbiased kind of here's what happened. And in the discussion section, it's like here's why what happened is relevant. All right. So, for example, for the melting point lab, you're using it to identify the identity of different compounds. All right, in the future. For the results section, you'll be like, okay, we got a temperature of this, and that corresponds to compound X. And then you're going to see that compound X is actually the unknown compound, and therefore you are confirmed in using the melting point as a way to identify different compounds. All right, and in the discussion, we'll talk about the significance of that. All right. Also, in your results section, you're going to show all the math that you do. All right, you're going to include calculations of theoretical and experimental yields, percent recoveries, et cetera, et cetera, et cetera. All right. You're going to be including tables. So all of the calculated results that you got, you're going to be putting them in nice tables, and that way we can see all of your data at once. And then the conclusion is basically you summarize what you learned from the experiment. You also talk about, in general, if this was like a lab report that you were submitting to a journal, you would talk about the relevant implications of that lab that you did. So for example, for the melting point lab, I should probably stop bringing up a lab that you're actively going to get graded on. But for the melting point lab, what you're going to be doing is you're going to be talking about, okay, so here's a general summary of everything that was happened. And then later on, what are the downstream implications of our results? So if your results were that, melting point does seem to be an accurate way to identify different compounds. Okay, so what that means is in the future, maybe you can use melting points as a way to identify compounds that you synthesize in your labs. And that could be one of the methods, one of the cruder methods that you can use just to make sure that your compound is what you actually think it is. All right? Hint, hint. That is what you'll be doing sometimes to identify your compounds. Any relevant post-lab questions will be done after the conclusion. Okay, and so that is the general idea of the roughly 6 parts if you include the abstract. And of course, once again, lab reports you do 1 week after each lab date in the syllabus, and then you get a 10% penalty for each week late. So for me personally, you don't have to send it in PDF format. You can send it in either PDF or Word format. That's fine with me. All right. I've attached a more in-depth file, how to write lab reports for those of you that might want a little bit more information. So first, you're going to be using passive voice over active voice. I mentioned this before. And here is a good example of what it means. Active voice is, of course, I did something. Passive voice is something was done. And the reason why we do that is it helps us eliminate bias and opinions and ego from our lab reports and try to keep them as objective as possible. All right. So as mentioned in the last the general lab format, your intro is going to take up a couple pages. It's probably the thing you're going to be spending the most amount of time and effort on, which is good because the intro is something that you can basically have finished before you even come to the lab. So it allows you to get your work done ahead of time if you're the type of person that's predisposed to do that. But it also helps me see that you understand the chemistry and what you're doing in this lab, which is why it's one of the more important ones for grading purposes, because this is where I see if that you're understanding the actual chemistry behind the lab. All right. So the first paragraph, you're going to usually identify some sort of problem, talk about an important discovery, or introduce some chemical phenomenon that is relevant to your experiment. So then you go into why that is important. And then you talk about a solution or topic of interest about the problem that you wish to explore. So for example, the synthesis of organic molecules in laboratory often leads to the synthesis of samples whose identity and purity needs to be experimentally verified. And that's your little hook. That's like, okay, we have an important problem. You're synthesizing these compounds in lab, and you have no clue how to tell if they're actually the thing that you want to synthesize. Okay, so why is this a problem? Well, since samples often cannot be readily identified by the naked eye, chemical analysis is often run in laboratories to verify chemical tests. And so this is why it's important, because we need some kind of test to verify what we're looking at. And then from there, you introduce how your topic that you're doing, in this case melting points, are a solution to that problem. Melting points are the temperature in which different solids melt and enter the liquid phase, which are physical properties characteristics of different solids. And although care must be taken to avoid jumping to conclusions based solely on melting point, scientists can utilize melting points to support the identification and purity of an unknown solid. Bingo. We have a problem. This is why the problem is relevant. Here's why the subject that we're studying is the solution to that problem. Bingo. That's your first paragraph. All right. Then the body paragraphs, you talk about the relevant background information that your audience needs to know to understand what you're planning on experimenting on. So in this case, assume that we know nothing, and therefore you have to introduce all of the relevant chemistry for understanding melting points, right? This is not just basic melting points, this is an organic chemistry lab. So if we're discussing melting points, we're discussing intermolecular forces, we're discussing structures, et cetera, et cetera. Okay, so start from the very beginning. Phases are defined in chemistry as chemically and physically uniform or homogeneous quantities of matter that can be mechanically separated. And so going into introducing phases, and then you go into the three phases, solid, liquid, and gas. And then you talk about changing from one phase to the other. And from there, you move on to the specific phase change, which is changes in melting point, and how that is a breakdown of the crystal lattice structure of a compound, and then how that melting point can be affected by purity, because the impurities will interrupt that compound's ability to form that crystal lattice, and therefore that's why melting points are a good way to measure purity. And likewise, they tend to be relatively rare to have two compounds that melt at the same point that are also being synthesized in the lab, and therefore melting points can be used as a way to identify compounds. Boom, 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 done. So that's general idea of why you're doing melting points. then all the relevant chemistry to understand it. And then from there, you go into a generalized framework of here's what I'm going to be doing in lab. Now that you understand why I'm doing melting points, what the relevant chemistry behind melting points are, from there, you're going to be doing a generalized workup of your experiment. In this case, I switched it because I didn't want you guys to get the entire melting point lab done for you. You'll talk about this experiment will in the future test the hypothesis that recrystallization will lead to the purification of acid analyte. To do so, we'll first be put into a solution of acetone and oil to help it dissolve. You don't have to know what this is yet. Just know the general idea is that you're talking about what you're generally going to be doing in the future. Whereas specifically, you would say 2.4 grams of acid analyte was dissolved in weighed using a triple beam balance. The material is then dissolved in 100.6 milliliters of acetone and heated to 104 degrees Celsius, et cetera, et cetera, et cetera. Notice how the specific sounds like what you did. The general sounds like what you're going to do. And it gives us a rough idea, no specifics, because the specifics you figure out as you do the lab, essentially. There is a general method section, which basically writes about what you did. In the previous lab format, you can just include it in results and discussion. All right. So for you guys, let's just get rid of this. There we go. So you tell us what you did in very specific detail and in chronological order so that any scientist that wants to look at your experiment and go, these are interesting results. I want to look further into this. I want to replicate it. Make sure that they have the full instruction manual. Think of it as like a cooking recipe. You include every single step that you're doing, how you're doing it, so someone else can copy that, whatever you're doing, right? It's the same exact idea. You want every detail, not a single detail left unmentioned. Okay? So then you also include a brief outline of any important observations made during the procedure, present any data that's collected in your table, and then compare your data to literature data in the table where possible. So for example, you got 136 for benzaldehyde, and I think, let's say benzaldehyde has a melting point of 134. This is what we got, and this is what the benzaldehyde's actual reference value looks like. All right. You're going to show any important calculations that you did, and then you're going to discuss any deviations from the procedure, any problems that you had, like your human errors, things like that. All right. The discussion section is going to be quick experiment on what the experiment was, quick sentence on what the experiment was, and then discuss the relevance of your results. All right. Was your hypothesis proven? What significance does that hold for you? You know, what are some future directions that you can take? What are some future implications, et cetera, et cetera. And post-lab questions, you do it here. And at this point, you'd want to go back and write your abstract after you've done all this so that you have all the information done, and then you just have to take a quick snapshot of your intro, your results, your discussion, your conclusion, your post-lab questions, and then put it back. So actually, This is the conclusion. This is the results. All right. So if you have any further questions, I will be available on Thursdays, 8 to 9 a.m. And if you want to make an appointment, Thursdays, 12 to 1 p.m. All right, so 8 to 9, I'll have a general Zoom meeting that you guys can enter to ask questions. And for appointments, we can do Thursdays, 12 to 1, but you have to email me ahead of time. All right. Thank you so much for your time and wish you the best of luck. We'll be starting our first lab next week on February 8th. And of course, it's going to be on melting points.